Okay, guys, I'm gonna record this last video. So here they want you to divide, so you can use long division, right? So this is b plus 10, and then we have to put the values here. That's gonna be b cubed 3b squared minus 76b minus 68. So it's gonna be b squared. It's gonna be b cubed plus 10b squared. Change the sign. So these cancel. So we get negative 7b squared minus 76b. Now we multiply by negative 7b, and we get negative 7b squared minus 70b. Change the sign. These cancel out. We get negative 6b minus 68. And then we multiply this by negative 6. So this is going to be negative 6b minus 60. Change the sign. Cancel out. So you get negative 8. So the answer is b squared minus 7b minus 6 minus 8 over b plus 10. Okay, that's the answer for this problem. Next one, just in case this is the answer. Okay. Next. So in this time, because this is binomial to the first power, I'm gonna use synthetic division. Okay, so a plus 10 equals to 0, negative 10 in both sides, a equals negative 10. That's gonna be here. So here we have 9, 95, 46, and negative 41. Notice that there's everything is in descending order: 3, 2, 1, and 0, right? So therefore, I don't need to put any placeholder. If, for example, if it was like from a cubed to a, I have to put in the second degree as 0 as a placeholder, but this time I don't need to do that. So this is, I'm gonna drop this. This is 9. This is negative 90. Combine like terms, you get 5. Negative 10 times 5 is negative 50. This is going to be 4. This is going to be negative 40. Let me double check if I put my signs good. You drop 9, negative 90, 5, negative 50. Here is negative 4. Right? 84. So this is positive 40. So this is going to be negative 1. Therefore, the answer is 9a cubed minus 5a squared minus 4 minus 1 over a plus 10. Right? And you can think about this as x cubed over, oh well, a cubed in this case, over a. So that's going to be a2 minus a3 minus a1. So you always get a second degree, one less than the one you start with, right? So if this is a cubed, you should get an answer. I made a mistake here. So this is a squared, a minus 4 9a squared minus 5a minus 4 minus 1 a plus 10. That's right. Okay, you always get 1 degree less than the one you started with. Okay, let's continue. Yeah, this is factoring by grouping, right? So if I'm sorry, not factoring by grouping, factor completely, but I have 4 terms. It seems like I have to factor by grouping. However, I need to check if that's gonna work, right? So 49 is 7 times 7, and this is 7 times 5. I'm sorry, 6 times 5. So they don't have anything to simplify, right? So this is going to be 49 over 30. And if I do these two, I have 7 and 5, and this is 7 times 6. The 7s they cancel, so I'm going to have 5 over 7. So it doesn't seem like it's going to work. However, if I work it out, if I rearrange them, maybe something helps, right? 42xb, that's these two. And then the other one will be 49yb plus 35 ub or yu, right? So let's do that. So here I have, this is 6 times 5, and this is 6 times 7, right? So that's going to simplify to 7 over 5, the ratio of those two, right? 7 over 5. And then this is 5 times 7, and this is 7 times 7. So if I simplify the 7s, I get 5 over 7, right? But I need to rearrange it then. It means the 35 goes here and the 49 goes there. So let's rearrange this. So this one goes here, this one goes here, right? And now it's gonna work. So this is 7 and 7, and this 7 and 5. So this cancels out and I got 7 over 5, and the other side I have 7 over 5. So this time it works, right? So now I can do factoring by grouping. So, okay. So now let's factor the GCF on the first group. So the first group is gonna be what? 6 and we say what 6, right? 6x, and then this is gonna be 5u plus 7b, and then the other group should be 7v, and then this is gonna be 5u plus 7y. Sorry, 7y, right? Yeah. Oh, this is u and b. They have y in common, right? So this is y. So they have, okay, 5u, and this is 7v, right? Now it's okay. Now you have the same, right? This is the same as that. So since it's factored, I just need to put them together. 6x plus 7y, and the GCF was 5u plus 7b. That's it. That's the answer. Next. Okay, next. Here I have what? If I do this, I have 7 and 5. This is 8 times 8, so that's not gonna work, right? So let's rearrange a different order. So maybe we can put these two together. 35xy plus 40my minus 64mx. So if I put it like that, that's not gonna work out. So I'm gonna put the smaller first, right? And then the bigger after. Okay, now it's gonna work out. Let's check. 8 times 5 is the 40, right? Or you can put 40 over 35. 8 times 5, 7 times 5. This one is 64 over 56. 8 times 8, 8 times 7. So 8 sevens, 8 7. So this works. So let's do factoring by grouping now. So we have 8, actually 5. 5y equals 7x plus 8m minus 8. This is going to be ax. 7x, that's going to be positive 56x squared. And then this is going to be negative 8, right? Negative 8m. So now you have the same. So this is going to be 5y minus 8, 7x plus 8m. It's supposed to be positive, right? Because negative and positive makes a negative. Yeah. So that's the answer, right? You have this the same as this, and then you have this the same as this, right? So that's the answer. Next. This is the difference of cubes. You have to check the GCF all the time. So there's no GCF here because this is only divisible by a and by 4, and this is divisible by 3 and 9. So they don't have a GCF. You can do a equals 4, b equals 3a. This is a plus b cubed, which is equal to a plus b, a squared plus ab, this is minus, plus b squared, right? So now you need to use a formula. Use the formula. So a is 4, b is 3a, right? And you should get the other values, right? So 16 minus 12a plus 9a squared. And if you take the discriminant here, this is a prime trinomial, right? So you cannot do anything. So you just leave it like that, okay? Next, this one, 6. So here I'm gonna change the letter because this is A and B, so I'm gonna change it to x cubed minus y cubed is x minus y, x squared plus xy plus y squared, right? So let A equals to let x equals a squared, right? Because if you square if you cube that, you will get a6, and y should be 3 to the b squared, because 3b squared to the third power equals 27b to the 6. Okay, so now let's do this. Okay, let's do. Okay, so this is a squared, right? Yeah, a squared minus 3b squared, that's x and y, right? And then we have a4 plus 3a squared b squared plus 9b to the 4. And I cannot do anything else more. Okay, I'm just gonna leave it like that. So that's the answer for this problem. Okay, so here they say evaluate each function. Now, if I plug this here, I'm gonna take forever, because remember in the test you don't have calculator, right? So if you do that by plugging that -6 to the 6th power, you're gonna take forever. You have to do, this is the remainder theorem, right? Remainder theorem, okay? That's on your slides. So what you need to do is, instead of doing plug the -6 in the function, which it will be correct, right? But since you don't have calculator, you can do this. You do the synthetic division, okay? So this is gonna be -3, -21, -17, 11, 32, 17, and 31, okay? And you put the -6 here. You put the -6 here, okay? And you do the synthetic division. You drop this. This is gonna be 18, -3, 18, 1, -6, 5, -30, 2, -12, 5, -30, and 1. So the remainder is 1, right? So that's the answer. When you plug f of -6 here, you should get 1, okay? And if you don't believe me, let's check. 7, 7. You see, it's 1, right? It's 1. Okay. Now here they say a polynomial function with rational coefficients has the following zeros. Find the additional ones. So they want you to find basically the conjugate pair, right? So this is 2 minus 2 radical 2, and this one should be -1 minus the square root of 2. That's it. There's 4. Here, -1 minus 2i, and here 1 plus 3i. You're done. That's it. That's the only thing they ask me. Here they say write the polynomial function of at least degree. Okay, so here they said these 2i has multiplicity of 2, but remember there's another 2i, right? Because this has a conjugate pair. This has a conjugate pair. So that means this is going to be x minus 2i, right? That's this guy right here. It has multiplicity of 2. And then you have the x minus 2i, right? Okay, and this one also has multiplicity of 2, right? Because if this has multiplicity of 2, this must have multiplicity of 2. So this is x minus 2i square. Sorry, I forgot about that. And then this is x plus 2i square. So now you need to square this, right? So the first one is going to be x squared minus 4i squared, minus 4i squared, right? 4i squared. So that's going to be x squared negative I squared. If remember, it's -1, right? So that's going to be plus 4, right? And then you have this guy, right? So we can do FOIL here because we don't have a formula for that. X plus 2i squared equals x plus 2i, x plus 2i. So this is going to be x squared plus 2x plus 2xi is 4i plus 4i squared, right? So this is going to be -1. So this is going to be -4 plus 4i x squared, right? X squared 2xi. Let me do this thing properly. So we have x squared plus 2xi plus 2xi plus 4i squared. So this is x squared plus 4xi plus, well, actually minus, because it's going to be I squared is -1. 81 times 4 is -4. Now you have these two, right? So this is x squared plus 4xi and minus 4. So you need to expand, right? You need to expand it, this thing. So let's do that. So this is x4. So I'm doing these 3 times, right? So that's going to be x squared, x to the 4. And then this is going to be 4x cubed I minus 4x squared. And then for the other one, I have to do these 3 times, right? So I have to do 4x squared, right? 4x squared plus 16 plus 16xi and -16, right? So that means these cancel. So I have x4. We have 4x cubed I plus 16xi minus 16. Okay, so let's check if something might be wrong here. Let's double check. So the x minus 2i, let's see, maybe I folded wrong. So this is x minus 2i, x minus 2i. So this is x squared minus 2xi minus 2xi plus 4i squared, right? So this is going to be -4. So this is -4xi x squared, right? And I need to FOIL this with the trinomial. Oh, it was different, you see? So I made a mistake. So here, this times this, right? So we have to do that 3 times, right? But if you notice here, you have now that I fix this, you have to notice that this is what? This is the difference of squares. You see? We have, let me double check this, let me close it. Yeah, this is x squared minus 4xi plus 4i squared, so it's -4. Yeah. Now we need to do this. Let me see if we can shortcut this somehow. There's no shortcut here. Nope. I have to do the long way. Okay, so you have to do these each 3 times. So that's a little bit annoying, right? So this is x4, and then this is going to be 4x cubed I minus 4x squared. And then here we have -4x cubed I minus 16x squared I squared. And then this is going to be plus 16xi. And then we have -4x squared okay, -4x squared minus 16xi, and this is going to be plus 16. Okay, so now you can combine like terms and hopefully something can, well, this cancels with this. So we have x4. Then we have negative 4x squared. So negative 4x squared. So that's negative 8x squared. So these two. We have x4. And oh, we have another, you see this one we have here. So this is going to be negative 16x squared, but negative I squared is negative 1. So that's going to be 16x squared. So this is going to be negative ax squared plus 16x squared is going to be positive ax squared. And then we have these two that they opposite, they cancel, and we have 16. So this is the answer. Okay, that's the answer. Let's check. So this is what I have, right? Copy. Number 10. This we need to check because this was a little tough. Not tough, but you know, you have to be careful, right? So they have the same as I have. Okay, be careful when you're doing the foiling and on the test of this thing. Okay. Okay. So next one. So this one we have to do. This one is going to be easy. 85, and this is going to be negative root 7, right? So we have to do x minus root 5 x. When it's, well, let's do step by step. Negative square root of 5 x minus root 7 x minus root 7. So you know what it is, right? So x minus root 5 x plus root 5 x minus root 7 x plus root 7. So this is the difference of squares. I'm gonna work it out with this one first. So this is gonna be x squared minus the square of this is 5. And then the same thing here, x squared minus the square root of that is 7, right? Remember, this is a squared minus b squared equals a plus b, a minus b. So that's the reason I'm squaring the a and then the b, right? So if you square the x, it's x squared. If you square the 5, you get 5, right? It's the same as this, right? Okay, that's the same. Okay, so now it's about expanding, right? So we have to do the FOIL. So this is going to be x4 minus, I'm going to try to combine them two together. So this is x4, negative 7x squared, negative 5x squared, that's negative 12x squared. This is going to be 35, and that's the answer. Okay, let's check this because these problems are little, that's 11, right? 11, that's here. So I have the same as them. Okay. Okay, that's the answer. Okay, next. It says state the number of imaginary zeros and possible number in the possible number of positive and negative zeros. Then factor and find the zeros. So basically, they want you to predict, right? State the possible number of imaginary zeros and the possible number of positive and negative zeros. So you need to estimate. So the way you estimate, you have to use the Descartes rule of signs. Okay. So how you do this thing? Very easy. You first evaluate the change in the signs, right? So because this is positive, I don't need to do anything. I just need to change how many times the signs they change. So you can make a table, right? You can make positive. I think that's what they do. Negative and imaginary and total, right? You can do that. So you compute this thing. So positive, how many times the sign change, right? Remember, you're gonna have 3 solutions. You know that, but they want you to find out the imaginary and the positive negatives. So there's no sign change from the positive 3 to the 7. There's no sign change here. There's no sign change here. So that means that this is 0 positives, right? What about the negatives? So you do f of negative x to check for the negatives. So you have to plug this negative here. So this is going to be negative x cubed because this is odd, right? Negative to an odd exponent is always odd, or negative in this case. This is going to be positive 7x squared, and then this is going to be negative 5x, and this is going to be plus 1. So 1 sign change, 2 sign change, 3 sign change. So there's going to be 3 negatives, and if the solutions are what? 3 values, then the imaginary should be 0, right? And the total should be 3, right? Now let's check if this is true, right? Let's check this is true. Let's check. You finding the zeros, right? That's how we check. So if we do factoring by grouping, let's see if it works. It doesn't seem like it's gonna work, because even though you switch the order, 3 and 7, they don't have anything. They're not gonna simplify. 5 and 3, no, they're gonna simplify. 7 and 5, they're not gonna simplify. 7 and 1, they're not gonna simplify. So we have to use the rational root theorem to find the answer for this, right? So the rational root theorem, or the rational zero theorem. Okay, so what that means? That means that I need to take the quotient of the remainder and the leading coefficient. I'm sorry, not the remainder, the constant and the leading coefficient. So what are the factors of 1? So that's going to be just 1, plus and minus 1. You can do the plus and minus 1 at the end anyway. What are the factors of 3? 1 and 3. So you take the quotient of that. So we have plus or minus 1 and plus or minus 1/3. So one of these combinations should give you one of the zeros of the solution. Let's plug 1 because 1 is easy, right? So we plug 1 here, f of 1. Let's see, we get 0. So this is going to be 3 plus 7 plus 5 plus 1. That's not 0. So that 1 is not, it's not working. So let's try negative 1. So f of negative 1. So this is going to be negative 3, 7, negative 5 plus 1. Let's see. So we get negative 8. Okay, that works. So that was one of the solutions. So we know that one of the solutions is x minus 1, and the x equals 1 is actually x plus 1, right? Because we said that negative 1 is one of the solutions. So this is one of the factors, x plus 1, right? Now we can use a synthetic division to find out what's the remainder, right? So this is, I mean, what is left? So this is 3, then 7, then 5, and 1. So this is going to be 3. You drop this. 3 times negative 1 is negative 3. This is 4, negative 4, 1, negative 1. So this is going to be 3x squared plus 4x plus 1. I need to factor this out. So x squared plus 4x plus 3, factor x plus 3x plus 1. That give me that. Divide by the original number, which is 3. So we get x plus 1. 3x plus 1. So that's the factor form. So this is 3x plus 1. And then x plus 1. Again, right? For a second time, we get x plus 1. So that means that this is multiplicity of 2. And based on this Descartes rule of signs, right? We're supposed to have 3 negatives, right? Right here, right? So how many negatives do we have? So if I set it equal to 0 because they want me to find the zeros, this is x negative 1 multiplicity of what? Of 2. That is negative, so that's 2. And then 3x plus 1 equals to 0, negative 1 in both sides. 3x equals negative 1. If we solve for this thing, we get x equals negative 1/3. So we have 3, this multiplicity of 1, right? So how many answers do we have? We have 3. 2, this one that repeats twice, and this number that is 1 time, that's 3. So the Descartes rule of signs was right? They give you 3 possible solutions. There are going to be 3 negatives. So that implies that this is the right answer. And you have to apply the rational root theorem to solve, because the factoring by grouping, doesn't work out here, right? Even though you have 4 terms, right? It seems like factoring by grouping might work, but it doesn't work. Okay, that's how you do that. Let's do the next problem. So here the same story, right? Let's see what happens. So by the Descartes rule of signs, let's see. We have positive, right? Negative. And what else? We have positive, negative. Let me put that here so we can save that the space. So negative, positive, negative, and imaginary and total. Okay, so what's the thing? I need positive, negative, and imaginary. So let's start with a positive. So there's no sign change. There's only one sign change. For the negative, let's see. 2 negative x to the second plus 5 negative x minus 3. So 2x squared minus 5x minus 3, one sign change, right? One sign change. So that means imaginary should be 1, right? Because the total, actually the total is 2. So this is going to be 0. So should be 1 positive and 1 negative. Let's see if this is true. So here I don't need to apply the rational root theorem because this is only quadratic, right? So I'm going to use, there's no GCF because this is 2, 5, negative 3. No GCF. I can use what? I can use the AC method, right? Let's see if it works. So this is x squared plus 5x minus 6, x minus 2, x minus 3, right? That's going to be 6. Actually, it doesn't work. Let's do 6 and 1, right? 6 and 1, that works. And this is supposed to be positive and this is supposed to be negative. Okay, so that works. Negative 6, 5. Now I need to divide by 2. So this is going to be 2x minus 1, x plus 3. Okay, so that's the answer. So the answer is supposed to be 1/2, and the x is supposed to be negative 3. So we have 1 positive, 1 negative, okay, and no imaginary. So that's good. It still predicts the answer. Okay, that's how you apply Descartes rule of signs. Okay. Okay, good. Here they say state the possible rational zeros for each and then find the rational zeros. So here I'm not gonna do Descartes rule of signs because you already know what it is, but I'm gonna try to solve the problem using factoring by grouping or the rational root theorem. Okay. So this is not gonna work by grouping, right? That's not gonna work because 11 is a prime number, right? That's not gonna work. That's not gonna work. So we have to use the rational root theorem. The rational root theorem works for all of them as long as they're real or rational, right? So here I can use what? Let's see. So I have to write the ratio of all the constant, right? So that's plus or minus 1, plus or minus 11. That's the only numbers that are divisible by 11. And then the leading coefficient, which is this, which is going to be plus or minus 1, plus or minus 2. So the ratio of plus or minus 1, plus or minus 1/2, then plus or minus 11, plus or minus 11 over 2. One of these 8 numbers should give me the 0, right? So let's start with easy ones, with the 1, right? Hopefully that works. So 1 is going to be 2, negative 9, negative 18, plus 11. Hopefully this thing works. So this is going to be 13, and then this is going to be, this is negative 27, so that doesn't work. So 1 doesn't work. Let's try negative 1. So this is going to be negative 2, negative 9, positive 18, 11. So we have negative 7, right? Negative 11, I'm sorry. Negative 11, cancel with this 11, so that is not working either. So we don't have the 1, it doesn't work. So let's try 11. So if we try 11, that's going to be painful, right? That's going to be painful. Let's try with the synthetic division, okay? Let's try 11 or 1/2, right? 1/2 positive. So this is going to be 2, -9, -18, 11. So this is going to be 2. That's going to be 1. This is going to be -8. This is going to be -4. This is going to be -22. This is going to be -11. Yes, that's the answer. So 11/2, right? I mean, sorry, not 11/2. 1/2 is one of the solutions. So 1/2 is one of the solutions. So that means that x minus 1/2 is one of the factors, right? So now with that, I can work it out the rest. So 1/2, I had it before. Let me see. There it was. Okay, 1/2. So 1/2 is x minus 1/2 is the factor, and then we have 2x squared minus ax minus 22. Yes. So now we need to figure it out what this thing is, right? We need to find the rest, but we are almost done right now. So let's see. So now I need to do AC method, right? Ax squared minus ax minus 44, and let's factor x 11 and 3 and 4. That's not gonna work. Okay, let's check. 44, 22 and 2, 11 and 4. I'm sorry, 11 and 2. That doesn't work now. So it seems like this is a prime trinomial, but let's check. Let's use a discriminant, okay? So b squared minus 4ac. So b squared is -a to the second power minus 4 times 1 times -44. So that's gonna be 64 plus 88, 176, right? 64, 84a, c. That seems like it's working though. Am I doing something wrong? Let's see. We said that it was b squared minus 4ac. So 8 times 22, 61, 7. Oh, this is going to be negative. Okay, so that's it. That's the, yeah, this is going to be a prime trinomial. Now, if you use the Descartes rule of signs, you could predict that, right? So this is going to be this prime trinomial. So this is the answer. Okay, they want you to solve anyway. Okay, they want you to solve because they say find all rational zeros. Okay, no problem. So this is x equals 1/2, and then we need to do the quadratic formula here to find the answer. So x equals -b, negative a. Remember, this is a, this is b, ax squared plus bx plus c equals to 0, right? So a is b is -a. The formula is x equals -b plus or minus b squared minus 4ac over 2a, right? So -b, negative or -b plus or minus b squared is -a to the second power 64 minus 4ac over 2a. 2 times 2 is 4. So this is x equals a plus or minus 64. This is going to be a positive number, right? So that's going to be plus whatever this is, a times 22, right? 22 times a, that's 16, 176. So 176 over 4. So that's going to be x equals a plus or minus. If I put 4, this is 180, this is 240 over 4, right? So x equals a plus or minus 240. So 240, let's try to break it down. 240, this is 80 and 3, 40 and 2, and then 8 and 5, right? So this is 2 to the third, 2 to the fourth. So I'm gonna do as 2 to the 4, right? 2 to the 4 and 3 times 5 over 4. So x equals a plus or minus, the 2 comes out, the 3 and the 15 stays inside. So that's gonna be 15 over 4. So this is going to be A equals, well, one answer is positive, one answer is negative, right? A plus 2 root 15 over 4, right? And then the other answer, actually, we can simplify that further, right? X2 equals A minus 2 root 15 over 4. You can factor here the 2, and then we get 4 plus root 15 over 4. So that implies that this is x1 equals 4 plus root 15 over 2. Yes. And then you can do the same here. So this is going to be the same thing, 4 minus root 15 over 2, because they're the same numbers with different signs. That's it. That's the answer. So it was long because we have to do the quadratic formula. That's all. Okay. This thing. Okay, that's not gonna work either, right? That's not gonna work. So we can take the rational root theorem, right? B cubed. So this is gonna be plus or minus 1, and then for the this is for the constant, right? So the constant p and the leading coefficient is gonna be 3, plus or minus 1, plus or minus 3. So that means we need to look for plus or minus 1, plus or minus 1/3. So hopefully 1 or negative 1 works. So if it's 1, it's 3 plus 7 plus 5 plus 1. That doesn't work. Negative 1. So that's going to be negative 3 plus 7, negative 5 plus 1. I think this one works. Yep. So one of the solutions is negative 1. Negative 1 is one of the solutions. That means the factor form is x plus 1. So let's see if it works for this one to reduce. So this is 3, 7, 5, 1. Drop the 3. Negative 3. That's 4. Negative 4. 1. Negative 1. That's 0. So that means that this is 3x squared plus 4x plus 1. Okay. So remember the factor was x plus 1. Now we need to factor this guy. So this is going to be x squared plus 4x plus 3. This is going to be x plus 3, x plus 1. That's 3. That's 4. Yeah. So that's the answer. So, I mean, this is the factor form of this one. So if this is the factor form. So what's the answer? X equals negative 1 multiplicity of what? Of 2, right? Because you can write this as x1 squared, right? These two together. And then this is going to be negative 3 multiplicity of 1, right? Multiplicity of 1. Okay? That's how you do that. Done. Next. Describe the end behavior of the function. The only thing you need to do is just tell how the function behaves. So this is an at exponent and the sign on the front is positive, right? So this is basically the same as the parent function of x cubed, right? If you recall, x cubed looks like this. It was on your slides. X cubed looks like this if it's positive, right? So that means the end behavior of this function should be like this. I don't know exactly where it goes, but it should be like that, all right? So as x approaches infinity, the end behavior, right? As x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches negative infinity. Okay? So you can think about it like that. You're supposed to have n minus 1 terms, right? For this polynomial function. So if you have degree 5, this is a degree, then you should get at least 4 terms. I'm not saying that it has to be exactly 4 terms, but at least 4 terms, right? So here, I'm not gonna do that because they just want me to describe the end behavior. So that's the end behavior. As x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches negative infinity. So you can just tell, right? And you might have at most you will have n minus 1 terms, which it turns to be 4. So you can have 4 terms, maybe 3 terms. I don't know, maybe you might have something like this. So there's 1 term, 2, 3, 4. I don't know exactly, right? But you can figure it out by using the x-intercepts, but then asking for that, so I'm gonna keep the problem simple. So the end behavior is this, okay? This one. He's asking you for the end behavior. So this is a parabola, right? The parabola, and it's negative, right? So you should know how to do that. I'm gonna detail about this thing because the parabola you need to know. So the parabola, if I want to find the vertex, right? The vertex, there's many ways I can do this, but since this is in standard form, ax squared plus bx plus c, right? I'm gonna use the vertex formula, sort of that. So that's gonna be negative b over 2a. So in this case, the vertex is negative of b. This is a, this is b, and this is c. So that's negative 6 over 2 times a. A is negative 1. So this is gonna be 6 over negative 2, which is negative 3. So that means the x coordinate of the vertex is negative 3. Now I need to find the y coordinate of the vertex. So what you need to do is just plug this negative 3 in the function. So this is going to be f of negative 3. So this is going to be negative 3 squared minus 6 times negative 3 minus 4. So that's going to be positive 9, negative 9, 18 minus 4. So this is going to be 9 minus 4, that's 5. So this is the vertex, negative 3, 1, 2, 3, 5, 1, 2, 3, 4, 5. Let's assume it's around here somewhere. And if you want to find the x-intercepts, you need to set, okay, x-intercept, you need to set the y value equal to 0, set y for f of x equal to 0, and solve, right? So 0 equals negative x squared minus 6x minus 4. So you can factor the negative. So this is going to be x squared plus 6x plus 4 equals to 0. So the negative disappears. So you have to factor this out. So x plus 4, x plus 1. So it seems that this is not going to work out, right? So this might be prime, right? So if it's prime, that means that it might be, because this is what, below the x-axis, right? Because it's negative, that might be below the x-axis. That's the reason we don't have a real solutions, right? It doesn't cross the x-axis. Therefore, we can say that this is what, x equals negative b, or do the discriminant to find out, b squared minus 4ac. So this is 6 squared minus 4 times 1 times 4. So that's going to be 36 minus 16, which is 20, right? So this is supposed to be a solution for this, right? Supposed to be a solution. Let me see. That factor. Let me do the discriminant of the original number. Let me 1 second. Let me find out what's going on. So this is negative b, negative 6 squared minus 4, negative 1, and negative c. So this is going to be positive and negative. This is 64. This is 16. We're supposed to have an answer. Let me check. What was the problem here? So yeah, if you factor the negative 1, that's a GCF, x squared plus 6x plus 4. Okay, let me see. Let's find out. So x equal negative b plus or minus b squared. That's going to be 36 minus 4ac over 2a. So this is 6 plus or minus 36 minus 16, right? Over negative 2. So this is 6 plus or minus 20 over negative 2. So this is x equals 6 plus or minus 4 times 5. That's 2 radical 5 over negative 2. So this is x equals, well, you can do this now, negative 3 plus or minus square root of 5. Yeah, so you're supposed to have this. And you also supposed to have the one that we get original, right? So this was a quadratic, oh no, sorry, this only two solutions because it's a parabola, right? So it seems that this is a rational solution. So it's supposed to be somewhere around there, but the vertex is here. So the graph should look something like this. Because this is negative, it's gonna go down, right? That's the reason we have those rational solutions, okay? That's the graph. Okay, so let's continue. Sketch the general shape of the function. So the general shape of the function should be something like this. Let's see if factoring by grouping works. It's not gonna work, but it's -1. Oh yeah, it works. X squared minus 1 minus x minus 4, right? The ratio is -1. Oh no, that doesn't work. Let me see. Okay, doesn't matter. So this is x to the 4 and it's positive. So the end behavior should be the same as x squared. So it should be something like this. Okay. So you're supposed to have n minus 3 terms. You can use the rational root theorem if you want to find out what's the end behavior. Sketch the general shape. So you're supposed to have at least 3 terms, at most 3 terms. You can use the rational root theorem to find out if it's possible. Maybe it's not possible. So let's check. So this is going to be plus or minus 1, plus or minus 2, plus or minus 4. And then the leading coefficient is going to be just plus or minus 1. So this is going to be plus or minus 1, plus or minus 2, plus or minus 4, because you dividing these numbers, right? Dividing this by this, dividing this by the 1 again, and divide that 4 by the 1. So those are the possible solutions. You have to check which one is the answer, right? So if you plug 1 here, that's 1 minus 1 minus 1 plus 4. That's not gonna work. This is -2. -2 plus 4 is 2. That doesn't work. What about -1? So this is 1. If you put -1 in the function, it's 1. And then you have -1 minus 1 plus 4. -1. This is positive 1 here. And this doesn't work again, right? So if you plug 2, so 2, it would be 16, 2 would be 4, 2 would be 2, and this is 4. So this cancels out, doesn't work. -2 is 16, -2 is 4, -2 is positive 2 plus 4. It seems -2 doesn't work either, right? It doesn't work. And the last one is 4. So if I plug 4, I get what, 16 to 56 minus, that's not gonna work, 16 minus 4 plus 4. So that's not gonna work, that's gonna be positive. If you plug the -4, right? That's not gonna work either. So it seems like it doesn't have real solutions or rational solutions, so they might be imaginary. But anyway, you can, if they want you to do a rough sketch, you can do something like maybe looks like this. So you're supposed to have three turns on this, right? Maybe you might have something like this. 1, 2, maybe. Okay, maybe. But since they don't cross the x-axis, right? So you might have something like something like that. We don't know exactly, right? We do need a graphing calculator. Since this test is not graphing calculator, I don't think they're gonna give you that. There's ways to do it, but I don't think they're gonna ask you this question because it's time consuming. You don't have a calculator. Okay, this one, the general shape. So this is the same as negative x squared. So you already know what's the end behavior, right? So it's supposed to be something like this. This is the end behavior. You might have 3 terms at most, right? N minus 1. Here, maybe factor in my group, it might work here. This is negative 2 and this, okay. So let's see. So we have negative x squared. We have x squared minus 2. No, it's not gonna work again. And then this is gonna be, the ratio works, but the problem is the factors, right? So that's gonna be plus 1 x minus 2. Okay, anyway, you can use the rational root theorem, do the same thing. I'm not gonna do it. You can play around with this thing, okay? 20. They want you to find this is like a function operation, so this is the same as f of x plus g of x, okay? You kind of distribute it. So what's f of x? 3x plus 5 plus g of x is x squared minus 4x. So this is x squared minus 4x. You combine these two, I'm sorry. You combine these two, this and this, you get negative x plus 5. So that's the answer. This one, negative x squared. This one is the answer, okay? 21, just basically apply the rule. So here they want you to find g of negative 7, right? So this is g negative 7 plus h of negative 7. So plug negative 7 in each function, respectively. So if you get negative 7, there you get 49. Apply here, right? G of negative 7, if you want to do step by step. So this is going to be 49 minus 7, right? So that's going to be 54, right? I'm sorry, 44. I'm saying 42. 42 plus and h of negative 7. H of negative 7 is 3 times negative 7 plus 2. So this is going to be negative 21 plus 2. That's going to be negative 19. So this is going to be 23, right? 23. That's the answer. Next. So here we have f plus g of t of 3, right? So you can say f of t over 3 plus g of t over 3. So you need to figure out what this is, right? So you need to plug this in each function, right? So this is going to be t over 3 cubed plus 2 t over 3 plus g of 3, right? So that's going to be 3 t over 3 plus 1. So this is going to be t cubed over 27 plus 2t over 3. And then here we have 3t over 3, which is just t. And this is plus 1, right? And that's it. You need to find like terms, nothing here, because they just want you to find that. Next. Here you have x plus 2 minus f, x plus 2. So you need to plug each in each function, right? So I need to plug the g here, right? So that's going to be g of x plus 2. So g of x plus 2 in that function, right? So that's going to be 2x plus 2 plus 4. So that's going to be 2x plus 4 plus 4. That's going to be 2x plus 8. And g of x, f of x plus 2, right? This is going to be minus. Plug this here. So if you plug that here, you get x plus 2 squared minus 2 x plus 2, right? So this is x squared plus 4x plus 4 minus 2x minus 4. Cancel the 4s. X squared plus 2x. Plug that here, x squared plus 2x. Don't forget to do that negative. So this is 2x plus a minus x squared minus 2x, right? So this cancels out. So you get negative x squared plus a. That's the answer. Okay, that's how you do that. Let me see how many of them. Wow, there's a lot of them. Okay, f of 0. F of 0 is 3 times 0, that's 0. Minus g of 0, that's going to be, put 0 here, that's going to be just 1, right? So it's going to be negative 1. That's it. Next, f of x is 4x plus 3 minus g of x is x cubed minus 3. So this is going to be 4x plus 3 minus x cubed plus 3. So this is going to be negative x cubed plus 4x plus 6. Okay, just fix it in descending order. Next. Okay. So this is f of n times g of n. Okay. F of n is 2n minus 4 times g of n is negative n squared plus n. So you need to FOIL here. Okay. So this is negative 2n cubed these 2 times. Okay. Negative 2n cubed plus 2n squared plus 4n squared minus 4n. This is going to be 6n squared, 4n, and negative 2n cubed. That's it. That's the answer. Next. F of 0, g of 0. Okay. So what is f of 0? Just put 0 in the function. So that's going to be 2 times g of 0. It's 0, 0. Right. So it's going to be 0. Okay. If you plug each in the function, then you multiply, you will see that it's 0. Here. So this is basically the same thing as this, right? You can play around with this. I'm not doing that. Okay. Here I have f of x over g of x, right? So what is f of x? 2x minus 5. And g of x is what? X squared minus 3x, right? So here I have 2x minus 5. Here I have x minus 3. Well, there's nothing much I can do about here, right? Yeah, that's it. Okay. You can play around with this one. So here, g of negative a, g of negative a, h of negative a. So what's g of negative a? Negative 24 plus 1. And then this guy is negative 24 minus 5 is 19, right? 24, yeah, minus 5, 19. So this is negative 23 over 19. Okay, you can play around with this thing. This is f of g of x. So f of x. So this is not like times. This is saying f. Be careful with this. F of x. Okay, so you need to find f of x. F of x is 3x plus 2, right? And then you need to plug this 3x plus 2 in the original function. So f3 plus 2. So this is going to be 3x plus 2 plus 2. So this is going to be 9x plus 6 plus 2. So this is 9x plus 8. Okay, be careful with these questions. Okay, so here we have f of 1. You need to find f of 1 and then g of 1. So f of 1, plug here 1, right? So you plug here 1. So then you get 1 minus 5, that's negative 4. And now you do g of negative 4. You plug negative 4 here. Okay, so negative 4 will be negative 16 minus 1, negative 17. Done. I'm not gonna do that. You get the point now. So here we have negative 4 times the function, right? 3n plus 5 minus 5 times gn, negative 3n plus 5, right? So this is going to be negative 12n minus 20 plus 15n minus 25. Combine like terms, 3n minus 45, okay? This is the same as that. Okay, this one is a little more difficult, right? So let's do this one. 3 times g of 9. So you put 9 here, right? You put 9 here. So g of 9, that's 18, and that's 13 minus 2 times f of 9. 9 is negative 27, negative 26. So this is going to be 39 plus 52. So this is going to be 1181, right? Now this one is a mix, right? So this is negative 4 times g of negative 4. You put negative 4 here. Negative 4, that's 0. So that's going to be 0 plus 4 times f of negative 4. You put negative 4 here, right? So you get, actually this is not right. So negative 4 g of negative 4 x, right? Negative 4x is here. So this is negative 4x plus 4. And then plus 4, negative 4 here in the f of that, right? So that's going to be negative 16 plus 4. I'll combine like negative 4x. So this is going to be negative 16, negative 4 inside that. Okay, 4 times negative 4, so that's going to be negative 16. Yeah, it's 4 times negative 4x, so negative 16x plus 4. Now you need to combine like terms, right? So this is 16x minus 16 minus 64x plus 16. So these cancel out. You get 40, not 40, 38x, right? Maybe 30x. That's the answer. So that's how you do this thing. Okay, find the inverse. Stay if the given functions are inverse of each other, right? So you have to do g of f of m. If that works, and f of g of m works, then they're inverse of each other, right? So let's see. G of that, right? So 3, that f of n goes inside. So that's going to be negative 2m minus 1 minus 4. So this is going to be negative 6 minus 3 minus 4. That's going to be negative 6n minus 7. Now let's do backwards. Negative 2 times 3n minus 4 minus 1. So this is going to be negative 6n plus 8 minus 1. So this is negative 6 plus 7. So that means that they are inverse of each other. Yes. Okay. You did the same. So the same thing you can do here, right? So you can do f of g of x and g of f of x. If that works, then they're inverse of each other. So what is, the first one is g. So I need to put g inside x. So this is x plus 2 minus 2. So this is x. And then here I have to put g of f of x, right? So I have to put x minus 2 plus 2. So they're inverse of each other. This is x equals x. Right? Find the inverse of each function. Okay, remember f of x is y, and you need to make this into y, right? Let's assume that this is x. Don't make it difficult for you. This is also x, okay? So this is y equals negative fifth root of x. Now you swap places, right? So this is x equals negative fifth root of y. Now you divide by negative 1 on both sides. You get this fifth root of y, and then you do to the fifth power. So this is y equals negative x to the fifth. Therefore, this is f inverse of this function. So that's the answer. The same thing here. Well, this one is easy, right? It's supposed to be plus 3. Let's double check. So g, this is y equals x minus 3. Swap places, and that, right? You can tell that's the function inverse of that. Okay? Simple. Okay, the equation of the circle, right? So the equation of the circle, okay, it's in standard form is x minus h squared plus y minus k squared equals r squared. This is the equation of the circle. In standard form, right? So HK is the center, okay? And R is the radius. So now let's identify the center and the radius. So here it will be the HK is basically, you can think about whatever is here, the opposite sign. So H is 2 and K is -2. R, so notice that everything is a square here. So this means that this 16 is R squared. So that means if you need to find R, it's gonna be the square root of that, right? R squared equals 16, take the square root of that, you get 4. So you can grab this thing, 2, -2, that's here, this is the center. The radius is 4 units every, like from this point, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So you just trace it this way. Okay, that's it. That's the answer. This one too, same thing. HK, just write in terms of the opposite, right? X goes with H, so that's gonna be 3. K goes with Y, so that's gonna be 2. The radius is 4, right? Because R squared equals 16. Take the square root of that, so that's R equals 4, right? So 3, -3, 2, so that's here. 4 units up, so 2, 6. Here, 1, 2, 3, 4. 1, 2, 3, 4, and then 1, 2, 3, 4. So you can trace this. So, okay, that's the answer. Okay, next. So now this is not in standard form. You need to complete the square now. Okay, so put the x's together, put the y's together, and then you move this to the other side, right? So this is gonna be x squared plus ax space y squared plus 2y space, and then this is equal to that -a that is on the right side. So now you need to complete the square. So this is gonna be, remember this is b over 2 square equals c. So b is 8 over 2 square equals c. That's gonna 4. That's gonna be 4 and square, that's 16. This is gonna be 2 divided by 2 is 1. 1 squared is just 1. So add 16 here, add 1 here, and this is gonna be x plus 4 square plus y plus 1 square equals 8, and this is 9. So that's it. The center HK is -4, -1, and the radius is 3. Okay? And you can graph it, right? -4, 1. And then you count 3 units up, 3 units to the right, 3 units to the left, 3 units down, and you trace it. Okay? Whatever, you need to go inside the circle nicely, okay? Okay, here, same thing. Subtract -16. So this is x squared plus 6x space, -16 on the other side. And then I have y squared minus ay space. So b over 2 square give you the c term. So this is 6 over 2 square equals c. It's going to be 3 square equals c. That's going to be 9. Here I have to do the same. So this is going to be divided by 2. That's 4 square. That's 16. So you need to add 9 here and add 16 here. So this is going to be x plus 3 to the second power, y minus 4 to the second power. And that's it. So this is equal to that. So this cancels out with this guy. So this is 9. So this is x plus 3 square plus y minus 4 square equals 9. So the center HK equals the opposite sign. So -3 goes with h because that's the x. The y goes with the k. So that's just going to be 4. And then the radius is, since these are all squares, The radius squared equals 9. So take the square root, r equals 3, because this is geometry, right? It's gonna be positive, the principal square root. So therefore, this is what, 3 for the radius, right? And 83.4 here, that's the center. And then you need to go 3 units up and do 3 units up, 3 units down, 3 units to the right, 3 units to the left. This is the same thing, right? So this one is area equals, area of a circle is pi r squared. They give you the center already, you just need to find the radius. So the area is 14 pi r squared. This cancels with that. Take the square root. So the radius is, well, actually, give me one sec. Actually, this is 14 pi, and this is pi r squared. I need the r squared, right? So 14 equals r squared. So that means that this is hk, right? X minus h squared plus y minus k squared equals r squared. Remember that this is the h and this is the k. So this is x minus 5 to the second plus y minus 15 to the second equals 14. And that's the answer. This one right here. Okay. Circumference. Circumference of a circle is 2 pi r, right? Circumference is 2 pi r. They give you the circumference. So you know the radius, it should be 1, right? So that means this is hk. So this is going to be x minus 6 to the second power plus y plus 13 in this case to the second power is r squared. So r squared is just 1, right? Because r squared, you square both sides, you get 1. Okay. I don't think they're going to give you these problems. So I'm going to do like a little bit more than that. And then I think you should be able to do that. If you want me to do this, I don't think they're going to ask you this. If you want me to do it, you just send me an email and you tell me if you want me to do it, okay? This is very easy, okay? So here they want the x-intercept and the y-intercept, they say sketch the line. So x-intercept means 81, 0, y-intercept means 0, 84. So just plug those 2 points, 81, 0, it's here, 0, 84 is here. So this is the line, right? This is the equation of this line. I mean, this is the graph of this line, my bad. So the same thing you do here, right? I think you guys can do that. Here they want you to sketch the line too again. So you can do the x-intercept. The x-intercept is set y equals 0. So x equals -12. So this is -12, 0. This is the x-intercept. Set y equals to 0. And then the y-intercept equals, this is all slope chapter. Set x equals to 0, right? So that means this is -3y equals -12, y equals 4. So this is 0, 4. So now you can do -12, 0. Well, that's somewhere around here. And then 0, 4, 0 for x, 4 for y. So that's a y-intercept. You trace this line and you see the pattern, right? Same thing here. You can do the same method that I did here. Y equals x, that's just an identity line, right? That's from your slides. Y equals x is the identity function. X equals 0 is just a vertical line, right? Just like this, okay? The slope is undefined here, okay? Yeah, you need to write this in slope intercept form, right? So you can do 1/4 y equals 1/8 x plus 1, right? So if you multiply by 4 both sides, you get y equals 1/2 x plus 4. So you find the y-intercept and you do the rise over run, right? 1, 2 to the right. So this is the graph. If they're asking you for the domain, it's all real numbers. The range is the same thing. The end behavior, as x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches negative infinity, right? You should know that. Here you can do the method that I did before, the x-intercept method, or you can do, well, let's see, you can do that by yourself. Okay, I know you can do it. here, write the slope-intercept form of the equation of the line given this thing, right? So you give you the slope and the y-intercept. So the slope equals 2x plus 3, right? That's it. That's the only thing you need to do. This is the slope. And this is the y-intercept. Actually, hold on one second. So y equals 2x plus b, right? So the y-intercept is given. So this is going to be 0, 3, right? Most likely it's going to be like that. So this is 3 for y, 2 times 0 plus b. So that was, yeah. So this is the same as 2x plus 3, like in the beginning I did. Okay. Write the slope-intercept form of the equation of the line, right? So they give you, first you need to find the slope. So what's the slope? So the slope is the change in y over the change in x, right? So what is the change in y here? The change in x, it's going to be from -2 to 3. That's going to be the change in x is 5 units, right? Yeah, and the change in y, it's 2 units, right? Okay, so that's the slope. You can do the slope this way: y2 minus y1, x2 minus x1. That's the way you've been doing forever. x1, y1, x2, y2. So y2 is -3 minus -5, right? Over x2 is -2 minus, this one is 3, right? I forgot the negative here. So this is going to be -3 plus 5 over -5. So this is going to be 2/5, right? And it's negative. So that's the slope, and they want you to write the slope-intercept form. So y equals, now you can use point slope form. Y minus y1 m x minus x1. So y minus y1. What is y1 here? You can use any point you want. So y1 is here is -5. So that's going to be -5 equals the slope -2/5 x minus x1, which is 3. So that's going to be y plus 5 equals -2/5 x plus 3. 6/5. You can simplify that further. So this is going to be subtract 85 on both sides. You get -2/5x minus, so 6/5 minus 5, right? So that's going to be 6/5 minus 25/5, which is going to be -19/5. So this is -19/5. So that's the answer. Okay, that's the answer. Okay, so they say write the equation, slope-intercept form of this one, right? So parallel means this slope of this line is 1/4. The slope of the parallel line should be 1/4 as well. So this is going to be m2 equals 1/4x plus b, right? So this is y equals 1/4x plus b. So you have 1 point here, x1, y1. So you can plug that in the function. So this is 2, 1/4, x is -4 plus b, and you find the y-intercept. So this is 2, -1 plus b, that's going to be 3. So that means that this is y equals 1/4 x plus 3. Okay, so that's the equation of that. And perpendicular means the reciprocal of that, right? So m1 is 2/3, m2 will be -3/2. So now you can use y equals -3/2 x plus b. You have this point x1, y1, plug it in, -3/2 times 2 plus b, that's going to be -3 plus b equals -3. So this cancels out, so b equals 0. So y equals -3/2x plus 0, or you just put this. Okay, that's how you do that. And then these things, right? The absolute value, how you graph it. Just think about, this one has a vertex, and the vertex is 0,3. 0,3, so 0,3 is right here. And this is a reflection over the x-axis, right? At this point you can just put values, right? The slope is -2/1. So you can do 1, 2, actually 2, 1. Yeah, this is going to be 2, 1, 2, 1, 2, 2, 1. Yeah, so this is the graph of this, right? The reflection. Okay, so the center, you set it yeah, that's how you do that. If you can plug values always, right? Remember, if you want to find the center and x equals 0, that's 0 times -1, that's 0, and this is going to be 0, 3. You can plug when x equals 1, let's say, that's going to be -2. Absolute value -2 is +2, but it's going to be -2 again from the negative outside, plus 3 is going to be 1. Right, so 1, 1. And then you can graph that way, like we did before. Okay, that's it. And this one you can do the same. This is going to be 0.83. So 0.83. So this is the vertex. It's going to have it's going to go upward because it's positive. There's no reflection. So the slope is 2 up, rise 2, 1 up, rise 2, 1 to the left. From here, 2 up, 1 to the right. From here, 2 up, 1 to the right, and then you graph it. Okay. Yeah, what is the domain? All real numbers. The range is from -3, including -3, infinity. What is the end behavior? As x approaches infinity, y approaches infinity, right? Or f of x, both is the same thing, right? You know f of x and y are the same thing. Okay, so f of x approaches infinity as y approaches negative infinity, f of x approaches positive infinity. And here, same thing, domain is all real numbers. The range is from negative infinity to 3, including 3. And behavior as x approaches infinity, y approaches negative infinity. And as x approaches negative infinity, y also approaches negative infinity. Okay. And after that, you have the midpoint, right? They're asking you for find the midpoint between, let's say, 1, 3. Let's call this point x1, x2. They want you to find the midpoint. I think I see in your chapter, midpoint. Okay, midpoint is just the average, right? Let's put this thing 5, 4. So the midpoint is just the average of those numbers, right? So midpoint is x1 plus x2 over 2, y1 plus y2 over 2. So that's just the average, right, of the x values and the y values. So what is the average, or what is the distance between these two numbers, right? That should be 6 divided by 2 is 3. That's a midpoint, right? And then between 4 and 3 should be 1/2, right? Or 3.5, right? Because 4 times 3 is 7. And then 7 divided by 2 is 3.5. So that's midpoint. If they want you to find midpoint, okay? If they want you to find the distance formula, right? What is the distance between 2 points like these two? You can think about the distance formula as Pythagorean theorem, okay? What is the distance from these two? From 1 to 4. I mean, from 1 to 5. That's 4 squared. What is the distance from 3 to 4? 1 squared. So the distance should be Pythagorean theorem of that, right? So that's going to be square root of 17. That's the distance. Now, if you want to use the formula that they give you in the book, same thing. You will get the same result. This is x1 minus x2 squared plus y1 minus y2 squared, right? So the distance equals, what is x1? 1 minus x2 is 5 squared plus y1 is 3 minus y2 is 4 squared. So you get the same, you see? So this is going to be -4 squared plus -1 squared. This is going to be 16 plus 1, that's going to be 17. So that's the answer. Same like before. So that's the reason I told you the distance formula is just Pythagorean theorem, right? Okay. I hope this makes sense, and thank you. And I hope you do good on your exam. Okay. Good luck. Thank you.